Hi guys, welcome to School Nut. So today we'll be seeing the allotropes of carbon as requested by some of them. So let's get started. So from day-to-day life, we have seen different forms of carbon like coal, diamond, and also those pencil leads that we use that are available in pencils. And so these different forms of carbon are called allotropes of carbon. And but why do we see different forms of the same type of material that is made up of? So this is because in each of these materials, carbon is bonded to other carbon atoms in different structures and forms. So that is why diamond is the hardest substance and graphite is slippery and it is a good conductor of electricity. So even though the chemical properties of all these materials of carbon are the same, but the physical properties are not the same because of the different bondings of carbon in these structures. So first, let's see the structure of carbon atoms in graphite. Graphite is a material that you'll find in pencil leads that we say. So here in graphite, the carbon atoms are arranged as hexagonal arrays or hexagonal layers, you can say. So you can see this is a hexagon and these are the carbon atoms that I've represented here. And this is layer 1 and this is layer 2. I've just taken it as an example. So let's see the first layer. Each carbon atom is attached to 3 more carbon atoms, right? Each one of them, right? So we know that the valency of carbon is 4, but only 3 valencies are satisfied here. So for the 4th valency, each carbon atom is attached weakly towards the 2nd layer or any adjacent layer. So like this, right? So they are weakly attracted. They form weak bonds between the carbon atoms from the 1st layer and the 2nd layer. So we know that graphite is really slippery and easy to write because of the arrangement of carbon atoms, and due to these weak forces between the layers will tend to slip on each other, and that's why we're able to write with graphite easily. Okay, so that's about graphite. So let's move on to diamond. So as you can see here, this is the structure of diamond. This is only a part of the structure of diamond. So, and it is the hardest substance ever because each carbon here is attached to 4 carbon atoms. So the valency is complete and it forms a rigid 3D structure that is unbreakable, okay? And that's why it is the hardest substance on earth. So diamond is used in jewelry and also for cutting glass, etc. And another allotrope of carbon that is majorly looked into is the Buckminster fullerene. So imagine a football with the classic football with white and black hexagons on it. So this is a football. Don't mind my drawings. And so you'll have hexagons on them. So each of the black and white hexagons are part of the football and they're attached together. So in a Buckminster fullerene, the carbon atoms are present in the corners joining the hexagon, right? These corner atoms are joined together to form a hexagon. So that's where the carbon atoms are present, and so that it's also called as bucky ball, and because it looks like a football in shape, and it has like 60 carbon atoms or even more than that attached like in the structure, And so if you have any more questions on allotropes or you want more explanation, so you can drop it in the comment box below, and stay safe. Goodbye, guys.